Welcome back to Advent of Code. Today we are working on day 23. Don't forget to drop a like, by the way. So in day 23 we are still with the crab from yesterday, from day 22, and we are playing some kind of other game. You know what, as usual, what we're going to be doing, we're going to be checking the input. So I don't know exactly, your present input is this, but what is the initial? Okay, so this is the puzzle input that we're going to be using first for the debugging. So here we're just getting the input and we're doing a parse int. That's, I would say, this is the easiest input that we've got so far. Yeah, really, it's just like I'm still running the program, just to make sure we're not doing anything weird, but this is it. So today we have labeling 32415, and in the big input this is also numbers that are unique from 1 to 9. Okay, why not? Makes sense. So we need to split this. So instead of doing the parse int here, we're going to be splitting that into an array of integers, and then we're going to be doing the parse int. That looks better. So actually that needed a bit more work, the input parsing that I expected. So we're going to need to do a specific number of moves. So here const moves equal 100. I think there is something in the example that says, okay, 10 moves. Let's try 10 moves. So of course we are going to be doing a for loop. That's what makes the most sense. And here we have our game logic. What is the game logic? The game logic is you need to pick 3 cups that are immediately clockwise of the current cup. So let current cup, we need to check what it is. So where do we start? The first cup in the list. So we're going to be here current cup index. We're going to start at this index 0. So we pick 3 cups that are immediately clockwise of the current cup. Okay, so what's annoying here is if we are at the end of the array, because we're going to need to pick cups that are at the beginning of the array. That's a bit annoying, but you know what? I think we're going to do that simply const picked. We're going to be doing an array, and we're going to be using splice like crazy. Splice is something in JavaScript that enables you to extract elements from an array. So if we remove one element, we get an array here. Okay, so that's not a problem. Picked, we want to pick everything that is index plus 1. So the length, so we're going to say let n, this is number of cups, it's input dot length, that's it. So in that case we need to do our input, and here we need to do splice. It starts at current cup index plus 1, and here we need to do that modulo n, and we want to remove one number. That's going to give us an array, and we need to concat this array with something very similar here, which is this plus 2, and then one more time we concatenate the result with this plus 3. So here we're going to be logging, picked, because as usual I try to really do things step by steps to make sure we have something that works fine. Okay. So what I want picked, but I want also to check the input here. Okay, so we want to remove 8, 9, 1. Oh, my bad. We have 8, 1, 5. So here we need to always do +1. The reason, okay, so we're gonna be doing that const let picked, and here we're gonna be doing another for loop, j between 1 and 3, because we pick 3 elements. Oh, the double cursor is weird. Okay, we're gonna say picked equal picked dot concat, and we want to do input splice this. The reason is that at each splice we are removing one element. So here we're removing this element, and then after this operation the element disappeared, so we need to, yeah, that makes sense. Now let's try that again. The first time we have 8, 9, 1, which is exactly what we wanted. We have here, and now we have 3, 2, yeah, and the rest of the array. So now we fixed our little bug, and everything is in picked. So we have the first step that is working fine. Then we select destination cup. The cup with the label equal to the current cup's label -1. If this would select one of the cups that was just picked up, the crab would keep subtracting 1 until it finds the cup that wasn't just picked up. Okay, so it looks like we need to remove these 3 cups after we select the destination cup. So I think here we need the let's destination cup, and it's going to be, we said, a label equal to the current cup's label -1. So current cup's label -1, so this is input of current cup index -1, and this gives us a value, and we need to find label -1. So we need to find the cup with a label equal to the current cup's label -1. So here this is the label, and we would want to get, I think it's better to get the index rather than getting this value. So I think, oh, that's going to be tough. The logic is interesting here. So, you know, let's just do it like that. Simply, we're just like translating the rules into code here. Maybe we need to optimize it, but at least we're going to try it that way. So here what I would say is I would check input.index of and this, and the danger here, the current, is that we could have a 0, and if we have a 0, what happens? If at any point in this process the value goes below the lowest value on any cup's label, it wraps around to the highest value on any cup's label. So it looks like it always starts 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like it's always starting at 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we're just going to be using that, and we're going to say if this, so let destination value, and if this is below 1, we want to set it at 9. if this goes below the lowest value, it wraps around to the highest value. And we said that both in our test and in our actual input, this is 9. So we're going to be just doing that. So if destination value below 1, then destination value equal 9. That's it. Okay, so we need to make sure that while to get the index of this cup here. So here we take the index of destination value. And here we need to check if this is, if destination cup is above or equal to current cup index plus 1. Okay, so here the problem is that we need to manage the looping around. So we need to make sure, let's do that. Wait, we need to make sure that this is not that. So we need to check, actually, we need to do a while loop while this is the case. So while this is equal to one of these, the three options. And the three options, we said this is either this one or current cup index plus 2 or current cup index plus 3. So here, by doing these little things, it removes the problems with the looping around. So instead of doing a destination cup is more than a specific value and less than a specific value, here we're just, because we have three values that are picked, here we just compare to each of these values. So we do that, and in that case we have that. We do destination value minus minus, I believe. Is that it? Keep subtracting 1. And this is the destination cup value. Then we check if the destination value is below 0, and if this is not, we do that. And I believe that with this, we should have our correct destination cup index. Okay, now we remove these three cups as asked. And now the crab places the cups it just picked up so that they are immediately clockwise of the destination cup. Okay. So basically what we need to do, we need to here to do input dot splice. The start is gonna be that's always like one thing with the splice. I never know when you insert something, here, where is it inserted? It is inserted instead. So here we remove this element and then we insert this one instead. So what happens when we remove? Okay, no, I think that's good. So what we need to do, we need to say splice. We said the first value is the start. So this is destination cup plus 1, I believe. Delete is 0, and then we want to add our picked element here. So like that, I guess. And we're gonna be trying this out. So after the first turn, we have 3, 2, 5, 4, 6, 3, 2, move 1, pick up this, and 3, 2. I am not sure I'm doing the right thing here. So we're going to say console log, we take the input, we take the picked, and then here we display the input again. So that should make things a bit cleaner. So actually let's write as well the destination cup, you know, so we have all of the information logged out. This is 4. Destination cup is 4. Is that right? Destination 2. Oh. My bad. So the problem here is that we have the destination before. So this is the index before we remove the picked elements. So that is challenging. So what we're going to be doing, we're going to take this and we are going to actually remove the 3 elements first, and then here we're going to do the same thing. We're going to do input -1. If the destination value is below 1, then it is set to 9. And now the index of is going to be, instead of testing here this value, we just need to say if this is below 0, it means that we haven't found this value in the input array. So if this is the case, then we need to do this destination value. I think that's fine now. So this actually simplified the code. So let's try that again. So here we have 3, 2, 8, 9, and 1. 3, 2, 8, 9, and 1. 5, 4, 6, 7. Yes, that is correct. So now we can let this run completely and just log the input in the end. The input in the end 5, 8, 3. Okay, so this is not correct. Final. Hey, this is fine, you know, this is totally fine. So move 1. We have 3. Oh, actually, I should be logging here. I should be logging the input before we do anything. Log the input here. So 3. I'm gonna check that manually quickly. I've just found the bug. So that's actually I forgot. I just stopped at this rule. I've implemented this rule correctly, but I haven't implemented this one, which is a bit sad. So the crab selects a new current cup. That's quite important. And in order to do that, we need to say this plus. However, we know that we need to wrap around the array. So I usually prefer to do +1 here, modulo n. That's actually the cleanest syntax for me to increment a specific value and make it wrap at the end. So now we can run that again. Oh, is that still running? No, we have some kind of an issue here. That's interesting. So we have an issue here. Most likely we are stuck in this while loop. So I'm just gonna debug the couple first turns to make sure we are in a better position than previously. Okay, so it's interesting here because we see a difference in the implementation. So here we have cats 4, 6, and 7, and destination is 3. So on my end, I would just like push these 4, 6, and 7 in here. However, here you see that they basically 3, 4, 6 is around here and 7 is here. So that's like broke my brain for a second. But because this is a circular data structure, it's okay. You can make it start at any point. On my end, I make it start at 3. But on their end, they are making start at 7, which is just as valid as what we're doing at the moment. So the pickup here is 913, and this is here where we are making a mistake. So that's a problem actually. So I need to understand a bit. So I thought it was valid, but it looks like there is something about this index here. It was 5 and now it's 8. Oh, okay. So actually I cannot store the cup index. I need to store the current cup value. And the reason is because this is data structure, a rotating data structure, we might not have the right value first because of this insertion and deletion. So here, instead of the current cup index, we're going to say current cup value. And this is going to be equal to the input of 0. And here we can say a const current cup index is equal, actually let's make a let. I'm sorry. Let current cup index, this is input dot index of current cup value. So that works. That works for this. Here that works still for that. However, here this is where the problem can happen. We need to say that the current cup value is equal to input dot index of current cup value plus 1, and this I need to modulo it. Is that it? Wait, we have the index plus 1 modulo n, and here we need to say what is that input of that. I think this is it. I think this is the correct setup. Let's try that. Okay, so this time we managed to run the 10 turns, and in the end we have 3, 8, 7. Oh, this is not correct. This isn't correct. So I believe this is something that I might be wrong. So we take the index of the current cup, we add 1 modulo n, and we take the value there. So really the problem is when we do this, when we add something here, when we remove and add stuff, it's just making things nonsense. So actually, so we need the cup. So basically, when we add stuff here, it might move everything in the wrong direction, and that's the main problem. So meaning here we have 5, and we add this at the position 3. which means that on our implementation, it pushes 5 a lot further. So by doing this, we make sure we have the right index even though we added more elements before it. And I believe this is all we need. But we have an issue, so I'm going to spend time looking through the numbers to see where we have an issue. Okay, I found the issue. So here in that specific place, we have an issue, which is that we are taking here everything that is after 8, which should be 9, 1, and 3. And it works for 9, 1, but then doesn't work for 3 because we are outside of the bounds of the array. So what I need to do here, instead of we did that, but we need to make sure, so const id is equal to that. So actually let's put that index. So let index, and we're going to say if index is more than input.length, in that case we do index equal 0. Actually more or equal to, and let's try that. So here we should see 9, 1 and something else. Oh, wait. Thankfully, I had my input variable was a const, and it caught the issue at compile time, or not at runtime, but at least here I need to assign 0 to index. So here we have another issue. So this is really cool because of this test case is very precise and helps us a ton. So here we're gonna say log, and we're gonna be logging the index. We're gonna be logging j as well. Oh no. Yeah. Let me wait. I'm gonna boot my IDE again. Okay, sorry for that. I was saying we need to output j and index, and with that we should already have some insights on what's happening. So actually we need to input as well the input array to make sure we are doing something right. Okay, let's see. So we are saying with these numbers we want to get the value index 7, so 0, 1, 2, 3, 4, 5, 6, 7, so 9. That's perfect. Then the value at index 7, which is 1, that's perfect. Then the value at index 0, which should be 3. That looks good. So it looks like we are doing a good job here. We fixed this bug, but we have another issue. Now let's run that again. We see that we have an issue, and the issue is most likely in here. So we're gonna have to log around here. That's interesting. That's definitely destination cup. That's definitely a big problem. Okay, -1. We keep having -1. Destination cup -1. That's a nice infinite loop. So instead of having just that, we're gonna be displaying also the destination value. So that's not a number. That's not what we like to see. Not a number. So let's see, destination value, index of. Okay, so maybe we're like going too far in the negative world. Destination value is less than 1, then we set it to 9. So I don't understand when this nan could happen. Destination value. Maybe here. Okay, maybe here already. Log destination value. Current cup index. Oh yeah. So here we remove some stuff. So we need to update current cup index. Yes, that's the problem, because here we removed some elements at the beginning of the array, so we need to update current cup index. Now we have something correct. We should not have not a number here, and everything is going to be fine. So let's try to run that again. So that was a small issue. Okay, now it runs very fast, and the end result is 5837. 4196. So we have the correct ending sequence, and that's really good. We need to start after the cup labeled 1. We collect all the labeled cups clockwise in a single string with no extra characters. So 1 should never appear, so we need 9 to 6. Okay, so we need to output from here to here. This is interesting. This is a bit of a challenge, because we need to now do this again. So what I would do is I would say a const index of 1 input.index of 1. That's not a challenge, this part. We're gonna say while let I equals index of 1 plus 1 modulo n, because this is a rotating data structure. I need to say while I is not index of 1, const result, and here we just need to add the elements to result one by one. So here we're going to say result.push, so that's going to be input of I, and now we can say we can increment the variable I by doing I plus 1 modulo n, and now we should be able to log result.join with an empty string, which means this is the end result 9265. Let me remove this extra logging outputs, that we just have our end result, and I believe this is correct. So now we can do that with our full input. You know what, I don't really need to put that in a file here. I could just say here const input equal, oh no, let me keep that in the file, because we're doing like this split and everything. So this is the new input, this is the new output. Is that the right answer? No, that's not the right answer. The answer is too low. Make sure you're using the full output data. So let's go back to our scenario, make sure we understand that correctly. This is the input. Oh, this is 10 moves. Was there an issue with 10 and 100 moves? Now we need to do 100 moves. Okay, so let's go back to the debugging input. Now we need to do 100 moves. And now we have this, and what should be the answer is this. So if I paste this here, can I? Oh no, I cannot paste in here. If I paste it, you know what? Let's put that in a new file. Okay. I'm just pasting it here, and this is my input. We have exactly the same, so this is great. So now, now that we have 100 moves, I can go back to this. That's interesting because the very small details really matter a ton in here. Oops. Okay, we are good for part 1. I'm gonna check part 2, but I'm a bit afraid this is gonna be a long one. So let me check that first. Okay, so I've read the problem statements and we made a lot of assumptions that are just not gonna work for this. So the different assumptions that we made is that what is that? Yeah. This thing about making sure it fits below 1, then it is 9, that is not true again anymore, because now if this is below, then below 1, this is going to be 1 million. And also, I'm afraid that this is going to be taking a very long time to compute. So I'm gonna still make an attempt here, a quick attempt, but I am afraid that this is gonna be just a nope for this. So here I'm gonna say function part 1. We're gonna isolate the two parts to make sure we don't have an issue of scoping of variables that are overwritten. So here we're gonna pass input. And I'm gonna call part 1 here. We're gonna copy the input variable. That should still run fine, you know. Now we're gonna do something similar for part 2. So I'm gonna start by just copy pasting part 1, you know, because we just want to do that. That's it. We need to rename the function to part 2. We still want 100 moves, if I'm correct. Oh, it's going to do 10 million moves now. Right. So 10,000, 10 million moves. So I think this is a case where they're going to test our data structure and optimization for part 1. So most likely, yeah. I don't need to go further and say that this is not going to work. The main issue here that I can explain right away is that this splice is, I believe, approximately O of n. So yeah, this is not gonna work for sure, because we have 1 million object in our array and we need to do 10 million moves. So yeah, that's approximately 1 million times 10 million operations, approximately, in terms of complexity. So this is just not gonna work. And this is why I'm just gonna end this today, right here. I think this is a very cool challenge, part 2, and I might do that in the future, but at least I won't be trying that today. And the explanation is really because the current solution that I have has a complexity that is too high. So we need to code everything from scratch again. So yeah, let me know if you want a video in the future with part 2 solved, but at least it's not gonna happen today. Thank you very much for the support in this series. One more time, don't forget to drop a like, a comment, to subscribe, and see you in the next one. Bye bye.